Hey guys, Pankaj here. Welcome back. So today we are going to learn what is Gaussian distribution and what is their PDF and CDF. Okay, so let me share my desktop. Okay, so as usual, we'll be importing necessary library, NumPy and Seaborn, Matplot and SciPy.stats to create some normal distribution. Okay, so the norm is the function. Using that function, you can calculate easily PDF and CDF. Okay, otherwise, I have already shown the formula also in previous video how to calculate it by using NP histogram. You get the count and bin size and divide each count by their total count. Okay, but here PDF formula will directly provide you the PDF. So let's go ahead and generate some random data. Here a equal to np dot random dot normal. Okay, so normal function takes location, that is LOC, is 0 and scale equal to 1.0. So if you remember guys, in the empirical rule when I talked about Gaussian normal distribution, right, how exactly it looks like. So let me share the whiteboard now. So Gaussian normal distribution. So what is the property of this Gaussian normal distribution? Your complete data will have this kind of bell curve, right? Where mu, that is your mean, will be 0 and sigma will be 1, that is standard deviation will be 1. Okay, then we talked about those properties of sigma equal to 1, sigma equal to 2, and here sigma equal to 3. It's similar here, -1, -2 and -3. So mu plus minus 1 sigma, mu plus minus 2 sigma, mu plus minus 3 sigma. So this will be having total 68% of data. This will be having total 95% of data, and this will be capturing almost 99.7% of data. That was the property of Gaussian normal distribution. Okay, so that's what this function will generate the data where mean will be 0 and standard deviation, that is nothing but scale, equal to 1.0. And if you're going to provide size equal to, let's say, 100, it is going to create 100 data here, 100 data points. Okay, and later we are going to calculate the norm. We are going to plot them. Okay, so how we can plot? Using SNS dot, or before plotting, let's calculate the PDF. So here PDF I can get using norm dot PDF and the data. So PDF will look like this. So I can just comment, and CDF we'll see later. So let's see by plotting using plt dot SNS dot line plot. Here X will be your A and their corresponding PDF will be your PDF. Okay, so Y equal to PDF. So this is what that your normal Gaussian distribution looks like, right? So if you see here, automatically that mu or the median, sorry, mean or median, you can say, they are coming at 0. The peak is exactly at 0, and their standard deviation exactly at 1 from mean. So this will be your 0 plus minus 1, that is mu plus minus 1 and plus minus 2 and plus minus 3. Okay, so that's how your PDF looks like. So there's a formula to calculate PDF. So if you see here, PDF equal to 1 upon root 2 pi exponential minus x to the power 2 divided by 2. Okay, so what this formula tells basically, so if you talk about this e to the power minus x square, right? So the moment you see x is going towards, let's say, from 0 to, let's say, higher value, right, what is going to happen? So more the value of x, the more negative it will write, it will be here, right? So the more the value of x, either it could be plus minus, at the end it is going to be negative value only, right? So definitely your y value is going to fall. Okay, so if you see here mu equal to 0, let's say you are at x equal to 0. Okay, so at that x equal to 0, your y equal to will be on peak. You can clearly see here, this is your peak. That's where your mean is getting presented here, correct? This particular portion. Okay, the moment you go x toward this side, either plus side or negative side, you see here sharply it is going to fall. Okay, and the more value it will be very steeply it is going to fall. So there could be some bell curve where you will see this kind of curve, right? So you see here, this will be your mean where it is equal to 0. And the moment you go x towards positive value or x towards negative value, you see here how steeply it is going to fall. And this fall is happening because of this particular formula. Okay, exponentially with quadratic equation, that too with negative value, it is going to sharply decline. Okay, so that's how you calculate the PDF. So you may wonder, like, how these kind of steeps are coming. That is happening because of that particular formula. Okay, so I can show this with the help of other values also. If you increase the bandwidth, let's say you have this particular part is what? This particular part is known as your spread, right? You see here, this is nothing but your spread. If spread is less, your peak will be little more, right? So let's say I will plot bell curve with different steps. So one spread is like this, another spread is like this, another spread is like this. Okay, so this spread here, spread is less means all your values are, coming between, let's say, 0 to plus minus 1 sigma. Okay, so here let's say mu equal to 1, and if spread is more means your mu is little high. This, let's say, assume, I'll just put let means we are assuming uh, standard deviation equal to 2. Here spread is little more, right? It means values are far away from mean, means they are spread little more from mean. So here your standard deviation could be 3. Okay, so that's what you can see here. If you are plotting multiple values with multiple different sigma, you will see the values will be different. Okay, so I can prove it by having another value. Let's say I'll just combine this. Sorry, not this one. Let's go ahead and merge all the cells here. So assume that I'm just using LOC equal to 0 and scale equal to 1. That is what we saw, right? Default. So I'm just going to combine this. Or I'll take PDF A. Let's take this as B, and here scale will be, let's say, 2. And this will be B. And let's take one more here. PDF A, I'll mention. PDF A. And this will be PDF B. I'm just showing like how this variance and that bell curve will change by just changing the scale factor or the spread factor. And here it will be C and PDF underscore C, and this will be C. Okay, so what it is giving now? Okay, rather doing this, I'll just make a simple way. Okay, let's do the KD plot. This can be done easily. KD plot A, and let it be default. Okay, there will be another KD plot. I'll just mention bandwidth equal to 2. Assume that this is sigma equal to 2. Okay, and here bandwidth equal to 1. Just assume that. And here bandwidth equal to 3. So this is what I showed there, right? In whiteboard. So more the bandwidth means your spread will be little more. Okay, you see here. So if you talk about this here, so this particular part is nothing but your sigma equal to 1. this particular part is sigma equal to 2, and here spread is more, so sigma equal to 3. Okay, so that's what I showed. So PDF will vary and their spread will vary based on the sigma or standard deviation. Okay, and yeah, based on the formula, if you calculate, so if you go from here to these are x-axis, right? So the moment you go from 0 toward this side or toward this side, sharply your graph will be declining. Okay, because steeply it will fall because of this particular formula, where PDF equal to 1 upon root 2 pi exponential x square divided by 2 because of this formula. Okay, so this is what I wanted to show about this Gaussian PDF curve. Now let's talk about CDF. So CDF is what? Let's again go back to your curve here. I'll go to another curve. Let's plot this. So this is your bill curve for normal Gaussian distribution. Mu equal to 0, then here 1, 2, and 3, right? So what it basically tells, right? Your probability density function where mean equal to 0 is somewhere here, right? So let's say I want to have what is the probability of getting let's say value as 1, right? So if you just draw a line here, and if you just plot horizontal axis and vertical axis, let's say here your probability, since we are talking about probability, right, this will be from 0 to 1 only, right? So let's say this is 0.2, 0.5, 0.6, 0.8, 0.9, right? So 80% is the probability to get value as 1, but this doesn't tell what is the total number of value, right? So that's where it comes as Gauss cumulative density function. So that cumulative density function is nothing but area under curve about this, right? So let's say if I talk about mu equal to 0, so if you take here, what is my value here? Let's say 90%. Just assume that, okay, I got the curve here. So 90% value which falls between 0 to mu equal to, let us some value. Here I'm just taking, let's say some value it is there. Okay, so what is the value of getting a value in the x-axis which is 0 or less, right? So 50% probability will come. So that is nothing but your area under curve between that CDF. Okay, so if you take cumulative sum of this PDF, that is going to point here. Okay, that's how CDF is being developed, right? I have already talked about this in the video. Okay, so if you plot the curve here, CDF, let's see how it looks like. So what I can do, I can just calculate CDF equal to norm dot CDF of given value A. Okay, and let's plot them together. So earlier we plotted this, right? Line plot A and line plot CDF. Let's plot together and understand. Miss the value. PDF of A. Yeah, this should be fine, right? So this is what I was talking. So let me use this pen once again and explain. See what is happening. So this is your PDF, okay, exactly at mu equal to 0, and exactly 50% data is coming here. Okay, if you talk about Gaussian normal distribution, mu equal to 0, exactly 50% of data, you see here, exactly 50% data falls below -2 to 0. Okay, and if I talk about this particular value, which is 1, it is falling exactly at 90%. That is the beauty of CDF. It tells exactly 90% of 90% probability of getting value between -2 to 1. Okay, so that's how you interpret the data and understand insight of the data by plotting PDF and CDF. Okay, so this is what I want to show, CDF and PDF about the Gaussian normal distribution. You may not be able to find this for any data which is not following the Gaussian curve. Okay, so remember this formula, how to calculate it and how to visualize it. Okay, in next video, we will be talking about what is standard normal variate. So those data which is not following the normal bill curve, right? Or the property of the Gaussian curve, how we can do the standardization of that data and bring it as mu equal to 0 and standard deviation as equal to 1, which we'll see in the next video. Okay, so I hope you liked it. And yeah, that's all for today. Thank you so much. Bye-bye.